radical reacting to form a radical and another molecule. And then the last one, termination step, usually involve two radicals. It's more like the opposite of initiation. Two radicals coming together to form a molecule. Do you understand? So it could be chloride plus chloride, the opposite of initiation, to form Cl2. It could also be CH3 radical plus chlorine radical to form CH3Cl. Is that okay? Let me just, to form CH3Cl. Is that okay? That one is a termination step. So to terminate means to bring to an end. You see this reaction, we've actually brought it to what? To an end by terminating it. Now, what actually the chain carriers in these reactions are the radicals. So we talk about the chain carrier, like what they make the reaction, they continue. Now the radical. But if the radicals now, we are now able to quench the radicals, like two radicals reacting with each other to form a molecule, with no radical being formed again, it means the reaction has come to an end. Are you getting it? You see the initiation step, we form the radical. Propagation step, the radicals are still there. But immediately we are able to like quench all the radicals, then that phase is what we call the termination phase of this reaction. Now the next one is combustion reaction. Now in combustion reaction, what we basically look at is alkanes, they undergo combustion to form carbon dioxide and water. They undergo combustion to form what? Carbon dioxide and water, which of course this and this. Is that understood? Alkanes undergo combustion reaction to form carbon dioxide and water. Now what matters is the number of carbon dioxide that will be formed and the amount of water that will be formed. Now this is the general reaction, where N is the number of carbon, where N is the number of what? Carbon. So if it is something like methane, CH4, number of carbon is 1. So we say CH4, that is for methane, because if you put 1 into this equation, it's going to give us CH4 plus number of carbon is how many? 1. That means our N is equals to 1. Is that okay? The number of carbon is 1. That is, our N is what? Equals to 1. Let me remove this to whether it will. Our N is equals to 1. So if our N is equals to 1, you are now going to have plus 3. This one is T misbehaving. 3 brackets 1 plus 1 divided by 2 O2 to give us 1 CO2 plus 1 is how many? 2 H2O. This is the product, this is what you are going to have, and then at the end of the day, this will give us CH4 plus 3 times 1 plus 1 is how many? 4. 4 divided by 2 is how many? 2. So 2O2 to give us 1 CO2, since it as what? CO2 plus what? 2H2O. Is that understood? So if our N is equals to 2, as in ethyl, what will it become? C2H, of course, 6 plus 3 brackets 2 plus 1 divided by 2 O2 to give us 2 CO2 plus N plus 1 is 1 plus 1. I mean 2 plus 1, which is what? 3 H2O, because N is what? 2. So that at the end of the day, you have C2 H6 plus 3 times 2 plus 1 is what? 7 over 2 O2 to give us 2 CO2 plus what? 3 H2O. This is liquid. This is what? Gas. Ethane is gas. Methane is gas. Of course, all these one will give us gas, and then here is what? Liquid. Is that understood? So that is basically how a combustion reaction takes place. And they actually emit a large volume or a large amount of heat, and that is the reason why these hydrocarbons are used as fuel. Used as what? As fuel. Is that okay? Because they emit a large amount of heat. This heat can be used for your cooking and doing all manner of things. Now, what this one is for complete combustion. So complete combustion of alkane will give us carbon dioxide and water. Emphasis on the word complete. Complete combustion of alkane will give us carbon dioxide and water. How about a situation where there is no complete combustion? During the complete combustion of alkanes, with insufficient amount of air or their oxygen, what is formed is carbon black. And that carbon black is what is used for the manufacture of our ink, printer ink, black pigment, and as what? Filter. What is the equation of reaction for that? Something like this. You have CH4 gas plus O2 gas. Incomplete combustion, you can put incomplete combustion, and then what we have here is carbon solid plus 2 H2O. Here is what? Liquid. Do you understand? So that is that for combustion. So for complete combustion, what you form is carbon dioxide and water. What varies is the amount of carbon dioxide that will be formed and the amount of water. You discover that the first one, which is CH4, form 1 molecule of carbon dioxide and 2 molecules of water. The one of C2H5, ethane, form 2 molecules of carbon dioxide and 3 molecules of water. If you do for propane for me. Propane has how many carbon? That's 3 carbon. If you do for propane, tell me the number of carbon dioxide and the number of this thing that will be formed. All right, so that is that. Why for incomplete combustion, of course, we said it forms carbon black, which is used in the manufacture of what? Black ink, black pigment, and as filter. Now, the next one is controlled oxidation, although this one does not usually come into the exam. When you heat alkane with regulated supply of dioxygen or air at high pressure and the presence of suitable catalyst, gives a variety of oxidized product. But this one, they will not really set any exam for you. Probably by 200 level or so, you might come across something like this. For instance, you have 2CH4 plus O2 and then copper at 523 Kelvin. That is at high temperature and pressure. This will give us methanol. Are you getting it? This is what methanol. So what we are trying to tell you is that controlled oxidation of methane can give us methanol. Now this methane, you can also oxidize it using molybdenum oxide to give us methanol and water. Something like this, CH4 plus O2, but this one you use molybdenum oxide. And this will give us methanol plus water. All right, now the same thing, manganese acetate rather will give us ethanoic acid, but this one, they are not common reaction. All right, the next one is isomerization. What is isomerism? Isomerism is more like compounds, a phenomenon where compounds have the same molecular formula but different structural arrangement. Now in isomerization, what can actually happen is, in the presence of anhydrous. Now, my dear student, when you hear the word anhydrous, it means without water. Without what? Water. Is that okay? In the presence of anhydrous aluminum chloride and hydrogen chloride gas, isomerizes to branch chain alkane. So, for instance, if you have N-hexane, let's just use hexane. In the presence of all these anhydrous aluminum chloride and HCl, it will give us what? Something like 2-methylpentane and 3-methylpentane. Are you getting it? All those ones, they are under isomerization. The most important thing you know is that one of the reactions of alkane is what? Isomerization. Then aromatization. This one is very, very important. Very, very important. Now, N-alkane having 6 or more carbon atoms on heating at a very high temperature in the presence of oxides of vanadium, molybdenum, or chromium supported over aluminum, get dehydrogenated. Dehydrogenated meaning you remove hydrogen, and cyclized to benzene and its homologues. This reaction is known as aromatization or reforming. It's known as what? Aromatization or reforming. Now, what we are trying to tell you is that N-hexane. What is N-hexane? CH3, CH2, CH2, CH1, 2, 3, 4, CH2, and then CH3. When you heat this, the presence of vanadium, oxides of vanadium, or chromium, or manganese, or molybdenum rather. Molybdenum oxide is MO2O3. Chromium oxide is CrO2O3. And then vanadium oxide is C2O5. And then you heat at atmospheric pressure of 10 to 20 atm. This one will cyclize to give us a benzene structure. This process is what we call aromatization. It's one of the reactions. Is that okay? Now, nobody will give you these equations in the exam. What they just want you to know is, they will ask, which of the following reactions can alkanes undergo? I've talked about combustion, talked about halogenation, I have talked about aromatization, I have talked about isomerization. Are you getting it? Then controlled oxidation. You should be able to state them. That is the most important thing. Nobody will ask you deep questions like this in the examination. Then reactions with steam. Now, maintain reacts with steam. This is just for maintain. Are you getting it? To form carbon monoxide and hydrogen. This method is used for the industrial preparation of hydrogen gas. What we are trying to tell you is you have CH4 plus steam. Steam is H2O, but gaseous H2O. In the presence of nickel as catalyst and heat, what will happen? This will form carbon monoxide plus what? H2 gas. This is used for the industrial preparation of what? Hydrogen. Industrial. So what we are trying to tell you is, in the industry, how is hydrogen prepared? Is that okay? That's the question. In the industry, how is hydrogen prepared? It is prepared by reacting methane with what? Water. Passing it through nickel catalyst at a temperature of 1273 Kelvin. Is that okay? So that is that. And then the last but not the least, which is of utmost importance in everything we've been doing here, is pyrolysis. Pyrolysis is also called cracking. This one you cannot jump it in the exam. It's already there. Pyrolysis or cracking. Now we'll talk about pyrolysis or cracking. We are talking about the breakdown or decomposition of large molecular weight alkanes to give us a mixture of lower alkanes, emphasis on high molecular weight, that is, large alkanes are broken down to give us lower alkanes. Is that okay? Alkanes and other smaller molecules. Such a decomposition reaction into smaller fragments by application of heat is called pyrolysis or cracking. And it can be achieved in two ways, thermal or catalytic. You use a catalyst or heat. Are you getting it? So that is that. Now, what happens in pyrolysis or cracking? For instance, let us say we have something like C6H14. And then, let me use this one to make an illustration. This is what happens in cracking. You have C6H12 plus H2, then C4H8 plus C2H6, and then we have C3H6 plus C2H4 plus CH4. You are going to be given a mixture of product. Now, what product is this? Of course, you agree with me that this is an alkene. Here is an alkane. Here is an alkene. Why is it an alkene? It follows the general formula for alkenes. What is the general formula for alkenes? CnH2n. So if n is 6, it will be 6 2 times 6 is how many? 12. Are you getting it? So this is an alkene and this is hydrogen. Like we said, it forms alkanes, and what? Other mixtures like hydrogen gas and so on. Then this one, C4H8, this is an alkene too, follows general formula. And C2A6, this is an alkane. So this is a lower alkane, and then this is what? An alkene. So when they give you alkane, and then you see that the alkane, they now broke it down to now start giving you something like alkene, and lower compounds. Know that that reaction is what? Pyrolysis or cracking. Now, for instance, this can form 3 products. This is an alkane. Why is it an alkane? It follows the general formula of CnH2n, which is like C3. 3 times 2 will give us what? 6. This is an alkene. This is also an alkene. And then this is an alkane. Do you understand it now? So that is that for pyrolysis or cracking. And I believe that brings us to the end of alkanes. Everything you have to do with alkanes. Is that okay? So you should be able to know the reactions of alkane. Any question that comes out under this, you should be able to at least answer it. Thank you very much for your time. We'll see you in the next one. Have a nice time.